Hello, my name is Roy Simpson. I'm a professor of mathematics at Kissimmee River College in Sacramento, California. In this video, I'm going to talk about how to create a system of three equations and three unknowns from an application or a word problem. In this process, we're also going to have to solve that application or word problem. So let's go ahead and tackle this. So here's the problem that we have. Juan is preparing a quart of fruit punch made of cranberry juice, apricot nectar, and club soda. Each quart of cranberry juice has 1,200 calories and costs $1.25. The apricot nectar has 1,600 calories and costs $1 per quart, and club soda has no calories at all and costs 25 cents per quart. Pretty cheap, actually. How much of each ingredient should one use to make a quart of fruit punch that contains 800 calories and costs 80 cents? Okay, pretty decent application here. Let's go ahead and make a drawing of this situation. So you have a vat here of, well, let's see, we have cranberry juice, so I'll let C represent the cranberry juice. To that, we're going to mix some more of a different liquid, and this different liquid will be our apricot nectar. And then with that, we're also going to include a final mix, and this will be our club soda. I'll use S for soda. Okay, and in the end, we want a mix. I'll call that M. So these sometimes pictures really do help out. In this case, I know that cranberry juice has 1,200 calories per per quart, so I'm going to call this my calorie level. Calories. That's per quart, by the way. So calories per quart. Apricot nectar has 1,600, and club soda has none. The mix, we want 800 calories per quart. The cost of each of these can be written right below. This is $1.25, again, per quart. Apricot nectar is $1 per quart. And finally, the club soda is 25 cents per quart. In our mix, we want it to be 80 cents per quart. Well, it makes some sort of logical sense here that we are going to be using quite a bit of the club soda, because the fact is that we need to drag the price down to 80 cents. So that we can't just use apricot nectar and cranberry juice. Now we'll have to make equations out of these. Now remember, C and A and S represent the amount of each. So the amount. And one thing that we had mentioned in the beginning that I kind of just forgot to write down, the question is asking how much of each ingredient should one use to get a quart, a single quart. So actually in the end, he just wants 1 quart. So that gives me one equation right there. That's C plus A plus S is equal to 1. The amount of cranberry juice plus apricot nectar plus club soda should equal 1 quart altogether. And now we also have a calorie equation. That's 1,200 calories times the number of quarts of cranberry juice we're using, plus 1,600 calories times the number of quarts of apricot nectar, plus 0 calories times the number of quarts of club soda, should come out to 800 calories times the number of quarts of the mix. And finally, we'll have a cost equation. $1.25 times the number of quarts of cranberry juice, plus $1 times the number of quarts of apricot nectar, plus 25 cents times the number of quarts of club soda, should equal 80 cents times the number of quarts of the mix. Of course, I could clean this up. When I talk about cleaning this up, I'm going to actually do a couple things. First, C plus A plus S is equal to 1. Well, that can be left alone. But the second equation here, you could divide each of these by 100 to get rid of the 2 extra zeros in the end, and actually you can divide them by 4 as well, so 400. So if I divide each of these by 400, you'll get the following. You'll get 3C plus 4a. There's no version of s there, and this is going to be 2. In the last little bit, you could either leave these as decimals, which is okay, there's nothing wrong with that, or you can multiply both sides of this equation by 100. It doesn't really matter which way you go here. I tend to, if I'm going to work on an equation, I tend to not like decimals, but this is actually faster if you leave the decimals there. But I'll go ahead and write it without decimals anyway, just because I can. Okay, so this is a system of equations we want to solve. We've set up our system, now we just need to tackle this. Let's see here. All right, so we have to choose to kill off a variable. Now, here's a hint. If you have a system of equations and there are holes in it, like in this case there's an empty spot where this s is, then you should kill off that variable. Because the idea of killing off a variable, in this case s, is to get two equations that involve only c and a. And the fact is, we already have one equation here that involves only a c and an a, this middle one. So I know that if I kill off the s using rows 1 and 3, I'll get an equation involving c and a, and I already have one as well involving c and a. So it reduces the amount of work I have to do. So what we'll do is we'll take negative 25 times row 1, and we'll add that to row 3. So negative 25 times row 1 is negative 25c minus 25a minus 25s is equal to a negative 25. And then row 3 is just 125c plus 100a plus 25s is equal to 80. And when you add these two up, you get 100 of those c's plus 75 of those a's must equal, and what is this, 55? I think that's what it is. That's 55. So that's one equation involving c and a. And again, like I said, the equation that's been highlighted here also involves a c and an a. So here I go. I get to write a new system of equations. 3c plus 4a is equal to 2. And the second system, well, if you look at, or the second equation, sorry, if you look at this equation here, 100c plus 75a is equal to 55, each of those numbers is divisible by 5, so I'm going to go ahead and divide those by 5 here. So dividing 100 by 5, I get 20c. 75 divided by 5 is 15. And finally, 55 divided by 5 is 11. So now we have our system of equations with two unknowns, two equations. Just have to choose which variable you'd like to kill off. In either case, it's going to be pretty nasty. I'll kill off the c's here, although you would just have the same amount of luck killing off the a's, but I'll kill off the c's. So I'll do negative 20 row 1, and I will add to that 3 row 2. A negative 20 row 1 is going to give me a negative 60 c. Let's see, a negative 20 times 4 is a negative 80 a, and a negative 20 times 2 is a negative 40. And then 3 times row 2 will give me a 60c plus 45a is equal to 33. Add these up, the c's cancel. This should be a negative 35a, and you add these up, this will be a negative 7. So that implies that a is 7/35. That reduces to 1/5. So I know that the amount of apricot nectar should be 1/5 of a quart. And now I will use that, a being 1/5, to find out what c is. I'll plug it into this equation here. So 20c plus 15 times 1/5 is equal to 11. Well, 15 times 1/5 is 3. I'll subtract 3 from both sides. I get 20c is equal to 8, or in other words, c is equal to 8/20ths. That does reduce to 2/5. So the amount of club soda that I need is going to be 2/5. Now remember, we need the amount of club soda plus the amount of apricot nectar plus the amount of, oh, I'm sorry, that's not club soda, it's cranberry juice. We need the amount of cranberry juice plus the amount of apricot nectar plus the amount of club soda to be 1 quart. Well, we already have 2/5 of a quart here and 1/5 of a quart there, so we should have a remaining 2/5 to go. So there we have it.